42 is over 2 pages, right?
That sounds right.
Bro, it's normal world history. It could not be that hard.
I was not good at history. I was really good at that. I just love my country. Yeah. Everybody's a shot.
Were you like really into like World War II tanks in middle school?
No, not even. I don't know. It's really interesting, but I don't care about the other two. Get out of here.
I mean, the rest of the world's a little generous. It's Europe. It's Europe.
A little bit.
Hey, I was checking AP Classroom, and I checked with Mr. Dean, who's over AP, and he said it wasn't an issue. But in AP Classroom, your first name is your first and last name.
Yeah.
So
You're
the only one that can change that.
I called them over the weekend, or Monday or Tuesday, and it should be fixed.
Okay. I just wanted
Wait,
to
I have
know.
to turn it in, but
Hey, that's the first.
no, it's fine. No, I'm like, I'm gonna get you. Hey, what are we doing?
42, yeah.
Thank you.
Yeah, that confused me on the AP test because I didn't know it was like that, and I was like, I don't know what I'm supposed to put for my names.
Oh, okay. I was just afraid it might like make it hard for you to get credit for your scores or something,
Yeah,
but
no, I fixed it because I was gonna send it to my college, and I was like, I should fix it before I think it's not me. Like, they have my last name with
I would.
if you did not give me assignment 42 in Google Classroom, I need that at the start of class.
They chopped his head off.
Would it better for me to turn in incomplete 42 or to turn in a complete late 42?
Well, if you turn in a late complete 42, you'll get half credit.
Okay.
If you turn in an incomplete, you get half credit now, but you can finish it later to get half of those points back.
So you get 3 points.
You can get 3/4 of the points.
Okay. Oh, you're right.
I dressed specifically for this class.
I got my girlfriend's best friend was like, he said, oh yeah, we got like 14 tickets, so I can do this. I don't know where, but
Huh?
Mr. Townsend, did you kill her always for the third time?
For the third time?
Gabby got 6
Maybe.
and got 8. So I'm going with Gabby.
Okay, good morning. If I don't have your assignment 42, this is your last chance for full points.
That's why it's decision.
Either Sonia's dad or Avery's dad. Although I think
Oh, I like that. I like that. Yeah, I like that.
Sarah, you need to go, on your way to lunch, you need to go see Miss Eagle. You know who that is? Third floor, green floor office. So Clark Wood. She's college and career counselor.
Did she say what?
Huh?
Did she say what?
She just said stop by. I'm guessing you just need to say something.
Okay.
It's like we eat small
That's what we did. We got mine on there, we were there, but we took it like, once we got like a 900 page.
I wrote like one shit.
I have a book set for me on that.
So I turned this in on regular. If you need
Sometimes it doesn't save. I'll just fix it. Yep.
Okay,
I can
thank
just
you.
get it in. Okay, last call. Anything else? Any other 42s for full credit? Thank you.
I don't want to say anything, but like,
What's the smell in here today?
I want to get that book. My team.
I broke down and bought a space heater, and it just smells. It's like brand new plastic or something. I don't know. Is it a good smell or a bad smell?
It smells like cleaning supplies or something.
You're the fourth person to say something today, so.
I don't know, I smell it.
All right, guys, we need to get started here. Settle down. Bell rang a minute ago. You've had plenty of time to settle down. We've got a lot of small things to take care of this morning. Those handouts that you picked up, most of these are going to go pretty quickly. The exception would be number 44. So like we have been doing is I'm going to just start you on this one. So I'm showing you something new, but I'm not going to give you the full time to finish that one. I will give you more time next class to finish that one. So 44 will take a few minutes, but then 45 and 46 are both super quick. So those won't take long at all to go over. And then finally, I'm going to ask that you go back and actually finish 43 from last class, where we practiced concave up and concave down from second derivative. So. Okay, so we have learned that the first derivative is great to find increasing, decreasing segments. We have learned that there's something called the first derivative test that was first derivative test. Derivative. There we go. Okay, the first derivative test. What was the purpose of the first derivative test? If you want critical points, it'll just ask for critical points. Very good. Relative max and mins. So you use the first derivative to figure out where it's increasing, decreasing. But then when you can see where it's increasing and decreasing, and therefore you can see the relative max and mins, actually finding the relative max and mins is the first derivative test. Well, the second derivative test has the same purpose. It's a different way to find relative maxes and mins. So your first thought should be, well, I'm comfortable with the first derivative test, so does that mean I don't need to know the second derivative test? And the answer is no, or yes. Wait, I don't remember the question. The point is you have to know both, because sometimes it depends on the information given to you. If you're given the function where you can find the first derivative, or you're given the first derivative, then sure, just use first derivative test. But sometimes on the AP exam, they give you the second derivative and force you to try to find relative maxes and mins from that. So it's not a hard thing to apply. It's not a hard thing to apply. But it is different. So, okay, so using this graph over here, where are the relative extrema? Or what does relative extrema mean? Sorry? Okay, so mark the two relative extrema. Okay, what do we know about the first derivative at those points? Notice this is the function, so what would be true about the first derivative? Okay, these have to occur at critical numbers. So that is where the first derivative is 0 or undefined critical numbers. What do we know about the second derivative? What do we know about the second derivative here? How do you know the second derivative is negative there? Very good, because it's concave down, and where it's concave up, the second derivative would be positive. So that's just reinforcing the stuff we've already talked about. So what the second derivative test says is if you have a critical number, so someplace where the graph is probably changing directions, instead of using the first derivative to figure out where it's increasing, decreasing, and looking at maxes and mins, what if you just use the second derivative? So if you know an x value is a critical number, and you know that it's the second derivative is positive, so you know it's concave up. Well, yes, it is concave up. That critical number where the derivative is 0 would have to be a relative min. It's got to be bottoming out if it's concave up. Whereas if it was second derivative was negative, meaning it's concave down, that means that the critical number where the derivative is 0 would be a relative max. So the relative mins and maxes still occur at critical numbers like the first derivative test. But again, the difference is if you're just using the first derivative, you're doing the little sign chart, you're thinking about when it's increasing and decreasing, so you can see the relative maxes and mins. For the second derivative, you can do the same thing, but instead of testing around the critical numbers, you would test the critical numbers, and if it's concave down, you know it's a max, and if it's concave up, you know it's a min. That's the entire second derivative test. Just forces you to think if it's concave down, that top point must be a max. If it's concave up, that bottom point must be a min. So, not overly complicated or anything, it's just another thing that sounds very similar to other stuff that we're doing, so keeping it all straight. Okay, so you could have a question like this on a test, and we are going to use the second derivative test, but I guess if it was on your test and it just said find the relative max, min, or both, if you wanted to do the second derivative test, you could do either one you wanted to. But if you wanted to use the second derivative test, you're going to need the second derivative. Now, where do relative extrema occur at? When what is 0? Okay, so at critical numbers, which is when the first derivative is 0 or undefined. So, like the first derivative test, you still have to find critical numbers. Those are still important for the second derivative test. So, you could take the first derivative, set it equal to 0. Looks like critical numbers are at 0, positive 1, and negative 1. X equals 0 is a critical number. Negative 1 is a critical number, and positive 1 is a critical number. So you can still do a sign chart. The only difference is if you wanted to do the first derivative test, you would plug in numbers around the critical numbers so that you can see when it's increasing, decreasing. But if you're trying to do the second derivative test, I want to know, is it concave up or down here? So I would plug in -1 into the second derivative, and that would give me something positive. When the second derivative is positive, it's concave up, which means that at x equals -1, we have a min, because it's down here at the bottom. At x equals 0, you plug that into the second derivative, you get something negative, which means during that time, I know it's concave down, which means that critical point needs to be a max, because it's at the top. And that's it. You would get the same information. It would be consistent with what you got from the first derivative. Okay? And again, if you want to know the concavity at x equals 1, plug 1 into the second derivative. If it's negative, it's concave down. If it's positive, it's concave up. And if that's a critical number and it's concave up, then here are your relative mins. It should kind of make sense if the graph is bottoming out, concave down, that you get a min. And here's your relative max. If it's concave down, then it's topping off and coming back down. But one of the big differences is first derivative test, you test around the critical numbers. The second derivative test, you actually test at the critical numbers. Yeah.
Why did you find the critical numbers from the first derivative and not the second?
Because critical numbers only come from the first derivative, by definition. Critical numbers are when the first derivative is 0 or undefined. Because the first derivative is like the slope of the function, and so I really just need to know when the slope is 0, slope is 0, slope is 0. If the slope is 0, it's probably changing directions. We don't need to know where the second derivative is 0, unless you care about when concavity is changing around. Okay, so let's try that again. This one's same idea, but the function's a little bit harder. So if we had to use the second derivative test on this, we would need the first derivative so that we could find the second derivative, but we also need the first derivative to find critical numbers. You still need critical numbers in the second derivative test. So the derivative of a number times x would just be that number. The derivative of cosine something would be negative sine something. Oh, okay, it's not so bad. I thought these derivatives would be a little messier. Derivative of a constant is 0, and this would be 2 cosine x. So I still need critical numbers. I still have to figure out when the first derivative is 0 or undefined. So set the first derivative equal to 0. Try to solve for x. The best that you can do is sine x here, so you will have to refer to the unit circle. Within one rotation of the unit circle, sine is negative square root of 2 over 2 at, well, y'all tell me. Okay, you're too slow. 5 pi over 4 and 7 pi over 4. Okay, these are critical numbers. Again, if you want the first derivative test, which most of the time you have an option, you would test around the critical numbers in the first derivative to know when it's increasing, decreasing. Then you can see the relative maxes and see the relative mins. But for the second derivative, you actually plug in these numbers into the second derivative to figure out if it's concave up or concave down during that time. At 5 pi over 4, cosine is negative. Positive times a negative is negative, concave down, which means at x equals 5 pi over 4, we have a relative max. Plug in 7 pi over 4. The cosine of 7 pi over 4 is positive. Positive times a positive is positive. When its second derivative is positive, it's concave up, which means that this is a relative min, just like it looks like. Relative min at x equals 7 pi over 4. So it's not that it's really even harder than what you've been doing, it's just a slight variation of what you've been doing. Now again, don't fall into the trap of saying, I like the first derivative better, I'll just always use the first derivative test. I like the first derivative test better. It's easier to just find one derivative than it is to find two derivatives. But again, sometimes, and I will do the same thing to you to make sure that you prepare for it, sometimes the question will just tell you where the critical numbers are and give you the second derivative and expect you to figure out if they're maxes or mins. So you can't just insist on always using the first derivative test. Likewise, you can't just always use the second derivative test. There could be, well, yeah, they could phrase a question where you had to use first derivative test. I think that's less likely, but okay, far less important, but if there's only one critical point, then that critical point would end up being an absolute max or min. So basically like a parabola. If this guy only has one critical point, it's either it's got to be the absolute biggest because it's always going down, or the absolute smallest because it's going up on both sides of it. Okay, I think that's probably a good stopping place for second derivative test today, but anything that's jumping out at you, anything you want quick clarification on, I'm just introducing it to you today. You should maybe summarize some of it in a word or two or a sentence or two. Make sure you have good notes so next class when you look back at this, you can remember what we were doing and you can do a few yourself. Okay. Then next up are the couple handouts that will go pretty quickly here, so make sure you're giving me full attention. I think the hardest part of this unit, and you've seen most of it at this point now, but I think the hardest part is just organizing all this stuff. There's first derivative tests where you need critical numbers and you need the first derivative and you test around the critical numbers and it helps you find this or that. And then there's the second derivative test that you test the critical numbers, but the critical numbers still come from the first derivative, etc., etc., etc. So even though the work is similar from question to question, a big part of this is organizing the information. So first off, let's talk about critical numbers. Critical numbers are the reason they are important is they are where a function, and you're certainly allowed to emphasize here or elaborate if you want to do more. This is where a function might be changing directions. I underline the word might because it's not a guarantee. You find them only from the first derivative when the first derivative is 0 or undefined. 99% of the time it's when it's 0, but also undefined is important. And then what type of questions would we need them, or when would we use them? So I would find critical numbers if I wanted to figure out where my graph is increasing or decreasing, because critical numbers are the places it could be changing direction, so I know what to test around. Or using the first and or second derivative test, I could find relative mins and maxes. So if the question said figure out where your graph's increasing or decreasing, or if your graph's asking you to find relative mins and max, you should be finding critical numbers. Okay, I have not emphasized this very much because it's not that big of a deal, but what do you think the difference between a critical number and a critical point is? That's really close. A critical point is going to be a critical number that is a point on the function, on f of x. So a critical number technically is any number that makes the first derivative 0 or undefined. If that point exists, we can call it a critical point. So for example, I don't know what the critical numbers of this are, but if you had a function that was like this, and you found that the first derivative is 0 or undefined when x equals 0, that's still a critical number because it's meeting this definition, but x equals 0 doesn't exist in this function because you can't divide by 0. So you couldn't call it a critical point because there's not even that point. Okay, and then inflection points. Inflection points, what are they? They are where concavity is changing. Concavity is. So, not might. It has to be changing concavity before you can call it an inflection point. How do we find inflection points? How do we even know where to start looking? Good. When the second derivative is 0 or undefined, almost the same thing as critical points, but they're not. They're something different. They're from second derivative, not first derivative. They just sound very similar. That's why organizing this in our head is so important. And why would I ever go about finding a critical point other than a question that asked me to find a critical point? Well, like what we talked about last class, and what you are going to practice some more of is if you care about when it's concave up and concave down. So concavity intervals. Inflection points are where concavity changes, so I would go about trying to find those to know when it's concave up and concave down. Okay, and then, so I'll be asking you, well no, I'll help you fit, I'll do this part for you. But the back page, I think you guys can probably tell me those answers. Okay, so if you plug in an x value, I've said this a few times, but it's starting to really become important. If you plug an x value into a function, that is going to give you the y value at that x value. It's going to give you the y value for plugging in that x value, which is great if you want to know a point. So a big part of what we are building up to, as I said when we started this, is function analysis. So we're trying to figure out what these functions look like with calculus. And if you can find a couple points, you can find when it's increasing, decreasing, you can find when it's concave up and concave down, you can find those points where it's inflecting, you get a pretty good looking graph pretty quickly. So this is how, if you want to plug in an x value into a function, it gives you the y value at that x value, which is good for a point. But if you plug in an x value into the first derivative, that would tell you the slope at that x value, which is good information if you want to know the slope there, or if you want to know if it's increasing, decreasing there. Because positive derivative means positive slope, means increasing. Negative derivative means negative slope, means decreasing. Okay, and then from last class, what happens if we plug an x value into the second derivative? What is that? What information is that telling you? That's going to tell you about the concavity at that x value. So I would do that if I cared about when it's concave up or concave down, which we call concavity. Or what would be another question where you have to get the second derivative? Okay, I couldn't hear any of that. Yeah, if you want to do second derivative test, sure. That's a little further than I was even thinking, but what if it asked you to find something? One of the things we talked about last time. There you go. If you wanted to find inflection points, and inflection points are where concavity is changing, you got to figure out what the concavity is. So you would need to be plugging in x values into the second derivative so you can see where it's concave up and concave down, so you can see where the concavity is changing. So I'm not saying anything new on this page that I haven't already told you, except maybe critical points. Critical point is a critical number that is a point on the graph. But I'm just trying to put it all in one place so that you can see how they are very similar, but also doing different things. Okay, on the back page, I want to do the first one together, and then I want to give you a minute to try them and to quiz yourself. So the way this works is it gives you a statement. If the function is increasing, then it's asking the first derivative. If the function is increasing, what do you know about the derivative? Good. So positive, greater than 0. Either of those is fine. You can put it in words, or you can just use a math symbol like I did. I want you to try these on this page to see how many of these you can do without a hint. And then we will say them together. But this doesn't take but a minute. And of course, any of them that you're not sure of or any of them that you miss, you should put a star by and review later. Everybody's here today. That's very unusual. Let's give everybody a minute. To catch up. Okay, so I'm going to ask you so I can see if there's any of these that you guys are not adding enough to. The first one should be a gimme, I guess, based on the second one, based on the first one. If f is decreasing, then the derivative is, okay, negative. If the function has a max or a min, what do you know about the first derivative? Okay, 0 or undefined. I heard at least one person say that. Again, I know you're probably going to get sick of me saying that, but then it's going to show up on a test sometime and you're not going to check it, so it's going to hurt you. Okay, what about if the function's concave up, what do we know about the second derivative? Okay, if it's concave down, second derivative is, okay. If the function has a point of inflection, what do we know about the second derivative? Very good. 0 or undefined. Much less likely to be from undefined, but still possible. Okay, if the derivative is switching from negative to positive, what does that mean about the function? What kind of minimum?
Relative.
Right, a relative min. If you miss this one or you're not sure about this one, Remember, you can always just sketch yourself a little picture. Derivative means slope. If the slope was negative and then became positive, it's a relative min. Same idea with the next one. If the slope was positive and then becomes negative, I'm saying slope because it says first derivative, it must be a relative max. Okay, what about if the first derivative is increasing? What would that tell you about the second derivative? The second derivative is not concave up. The function's concave up, but not the second derivative. They're two different graphs. A function might look like this, where his derivative would be something like this, where his second derivative would then be something like this, because it lowers the degree each time. If it's quadratic, you take the derivative, it becomes linear, you take the derivative, it becomes constant. This is not concave anything. Okay, so good. This is what I need to know. If you want to know something about the second derivative and you have the first derivative, how can you go from first derivative to second derivative besides taking the derivative? Okay. Yeah. You go ahead and say all that again.
Slope.
Yeah, slope.
The second derivative is subtract the slope of the first derivative. Yeah?
Correct.
So it's greater than 0. It's increasing.
Correct. It is positive, which I know that's what a lot of people were talking or thinking about when you said concave up. So because of this, then sure, the function is concave up if you needed to know that, but you should know that from up here. So that's why I'm not referring to that. If the first derivative is increasing, it means its slope is positive. If the slope of the first derivative is positive, that's the same as the second derivative. Slope of first derivative is second derivative. So same idea with this one. If the slope of the first derivative is negative, it means the second derivative is negative. The slope of the first derivative is how you get information about the second derivative sometimes. Okay, and then if the derivative has a max or min, so if I graphed it and he had a max or a min, what would have to be true about the second derivative? Good. It's got to be 0 or undefined. The slope at those times would have to be 0 or undefined. Again, we're just trying to organize all this information in our head. Some of these are a little easier than others. Put a star by the ones that you didn't know. Maybe highlight the part that you didn't put enough on. Like if you just put this and you didn't put that, emphasize it in some way because this is trying to sum all that information up for you. Okay, and then finally, the last part we need to talk about together on the board is now that we have talked about points from the function and increasing, decreasing from the first derivative and concavity from the second derivative, we can start moving into some of the curve sketching stuff, which is where we are going to estimate what some graphs look like. So this last handout for today this top little row here is a question where I'm giving you the first derivative graph, which is the most common type of graph you will see in calculus. And from this, we should be able to sketch what we think the function looks like and sketch what we think the second derivative looks like. Okay, so if the first derivative is positive, like it is here and here, when the first derivative is positive, what do we know about the function? It's what? It's increasing. So from 0 to infinity, my graph needs to be increasing. And from negative infinity to negative 2, my graph needs to be increasing. Now, I have no idea where it starts increasing or what it stops increasing to. I don't know the y values. You got to get over that. I don't have enough information to make this exactly perfect, but first derivative is positive, the function is increasing. The function's going up. When the first derivative is negative, your function's going down. So I need to make an adjustment here. I need to make this go down from -2 to 0 without messing up the other part. Now, if you have multiple colored pens or anything, I think that they're pretty helpful here because it kind of shows you the colors here are matching up the colors here. Positive first derivative increasing, negative first derivative decreasing. Now, we can do better than that, but that's a good start. So let's go do the second derivative, and then we can come back and make this look a little bit better. Okay, when the first derivative is increasing, going up, what do you know about the second derivative? Okay, so the first derivative is increasing from -1 to infinity, so the second derivative should be positive from -1 to infinity. The first derivative is decreasing, meaning a negative slope, and a negative slope means a negative derivative. When he's decreasing, second derivative is negative below the x-axis. When the first derivative is increasing, the second derivative is positive, which means above the x-axis. Now, before we go back to the function and make it look a little nicer, I kind of mentioned this a minute ago, but this going from this graph to this graph to this graph, let me erase this. Well, actually I kind of like it there for the colors, but what is happening, what can you say about this graph and how it changes to this and how it changes to this? The degree what? The degree goes down by 1 each time, which should make sense because think about if you have some function like x cubed, when you take its derivative, the degree lowers by 1, and when you take the degree again, it gets lowered by 1. So this might be something like a cubic equation, but his derivative is going to look like a quadratic equation, and his derivative would then look like a linear equation, right? You take the derivative, you're lowering the power by 1. So the number of turning points can go down. So this should look like cubic, quadratic, and linear. It definitely just can't go the other way, is all I'm saying. Okay, so why do you think I'm not happy about this? What can I make this look a little bit better based on what we know? Very good, the concavity. If I know the second derivative is positive during this times, that means I know it's concave up. So add a little bit of curvature to make it look like it's opening up. And when the second derivative is negative, we know it's concave down. It doesn't need to be jagged like this. It needs to be opening down. And then that's good enough. That's as much as we can give without more information. Now, if I said, by the way, your function needs to hit this point, and this point, then yeah, your graph could get more and more accurate. Okay, I would like you to try the second row. So take this first derivative, think about what we did to the first derivative to try to find the function, just give it your best sketch, then worry about the second derivative, and then maybe come back to the first derivative and make it better with the curvature. you're stuck, that's fine, but let's try to help you think about what you didn't consider. So, it's not like there's any order to this. You can start with whatever you're most comfortable with, but to me, I know when the slope or the first derivative is positive, I know my graph's going up. So again, I don't know the y values here. I just know that it needs to be going up from 2 to infinity and from -3 to -1. Again, I have no idea what the y values are. I'm just guessing. Well, I'm not even guessing. There's no way to know. I just know it's going up during those times. When the first derivative, so you don't have to change your paper. Yours could still be fine. When the first derivative is negative, that means that the slope is negative, so it should be going down during these times. He's going down from -infinity to -3. And he's going down from -1 to 2. So that's possible like that. It's increasing at the right times and it's decreasing at the right times. First derivative is positive, it's going up. Second derivative, first derivative is negative, it's going down. That's all I've done. And of course we can worry about the concavity after we think about the second derivative. So, second derivative, when the slope of the first derivative is positive, or when it's increasing, same thing. Let's say increasing, that's a little better. When the first derivative is increasing, that means the second derivative is positive. And positive means above the x-axis. So it needs to be above the x-axis till x equals -2. It needs to be above the x-axis after x equals 1. And when he has a negative slope, he has a negative derivative. So that part needs to be below the x-axis, and of course it needs to connect. Now, that's kind of funny looking. Again, I'm just, and this is fine, there's nothing wrong with that, but I suspect it probably looks a little more like a quadratic, so I can make it look a little nicer. And now that I know where the second derivative is positive and negative, I also know where it's concave up and concave down. So going back to the first graph, it should be concave up from 1 to infinity. So here's 1. This would be the inflection point. So I just try to make this look like it's opening up a little bit without messing any of the other stuff up. It still needs to be increasing. Well, it needs to be decreasing and then increasing. I know the second derivative is negative from -2 to 1, and when the second derivative is negative, it's concave down. So I need to make it concave down from -2 to 1 without messing up the other stuff. Make sure you're still got it increasing and decreasing during the right times. And second derivative is positive from -infinity to -2, so it's going to be concave up from -infinity to -2. So don't mess up the increasing, decreasing segments, but give it some curvature. Okay, if you had to guess, because you don't really know, what would you guess the degree of this polynomial to be? That's a very good guess. Why are you guessing 4 based on this?
Second derivative looks like a quadratic.
Okay. Okay, what if I just gave you this though? If you're just looking at this, how could you know it's probably degree 4? Very good. The degree -1 is the maximum, not the guaranteed, but the maximum number of turning points. Since this has 1, 2, 3 turning points, it's at least a degree 4, which means that its derivative would be a degree less than that, which means it has at most, not guaranteed, but at most 2 turning points, which means his derivative would be degree 2, which means it has at most 1 turning point. So that should kind of help make you feel better about the shapes of your graphs. Okay, I will do one more of these for you on the board for those of you that feel like you need it. So I will do this one after I give you a minute to try it, and then the last one I'm going to leave to you to compare with your neighbor. But I will quickly share my answers to those after a minute. So if you haven't done those yet, please do it now. And again, this is called curve sketching. There's no way to know. Your graph can end up looking a little different than mine. It can look a little different than your neighbor's because we don't have specific y values that it's going up to or down to, or how much it's concaving up or concaving down, if that's the term. But the shape, the times it's increasing, decreasing, and whether it's opening up or down needs to be consistent. Wasn't one of your book assignments, recent book assignments, didn't it have a question or two kind of like this? Okay, good. I try to get you to start thinking about it a little early. So which one do y'all think is easier? Figuring out something about the function or the second derivative? Okay, I will do that one first then. So when the slope of the derivative is increasing, that means his derivative is positive. Positive till about x equals a half. When the slope of the first derivative is decreasing, that means his slope is negative, which means his derivative is negative, which means below the x-axis. Positive just means above the x-axis, negative means below the x-axis. Again, I don't know how quickly this is going up or how it's going down, but it's important that it's switching here. This looks like a second degree, so it makes sense his derivative would be linear. The degree goes down by 1. Okay, going from the first derivative to the function, unfortunately, that you didn't say, this one seemed easier. This is probably what's asked more often. But when the first derivative is positive, we know the slope of the function is positive. So he should be going up from -1 to 2. Again, I have no idea the y value that starts at or ends at. I just know it's going up. When the first derivative is negative, I know it's going down. So something like that. And then to make it look a little bit better, we can add some concavity to that. Where the second derivative is positive, it should be concave up. So without messing up when it's going up and down, just give it some curvature. When the second derivative is negative, it's concave down. Same thing. Don't mess up the increasing, decreasing intervals, but give it some curvature so it opens down. This looks like a third degree, which makes sense that his derivative would be a second degree, which makes sense that his derivative would be linear. So, if you feel unconfident, if that's a word, I will check yours. I need to do it on my paper. I haven't done it this year. So, do the last one, compare with your neighbor. If you want me to check y'all's and make sure yours is okay, I'd be happy to do so. But make sure you feel okay with that first. And then you've got roughly 35 minutes to look at what we did on assignment 43 last time on Monday. And I'd like you to finish that one. Now, this is a B week. I feel like we haven't had a B week in forever, but it is a B week, so I will not see you again until Monday. So if you do have to finish up 43 for homework, you've at least got almost a whole calendar to do, a whole calendar week to do that. So. As you finish that last row, if you want me to scan your paper and double check that it's correct, I'd be happy to do so. Anybody else ready for me to check your last row? Good. Should. Yep. That's your watch right next to you. Feels nice. Today during advisory, I did share the solutions to assignment 43 too, so that you can check. I didn't share those last time because I wasn't expecting you to have it done today, but if you're struggling with one, you might use that to help. How big is your binder now?
So why does it go like that?
Is that just for the plus?
No, it's just
Oh, okay.
by. It's for all the
Where's your interest?
Are you stuck?
Hey, Jeff. No, I know, but don't you have to like go somewhere?
Where? No, it's like work. So someone's trying to shadowing at like 11. Yeah. That's right. Oh, wait, 6? No.
Brandon's mom.
Because it's an increase,
You wanna do-
so maybe
Supposed to be a baker.
All the calculus you can do is all the concavity of the donut.
I checked this for the record, so like. Put in. They are like.
Anytime someone brings up the that's why I think that's not like a bad way, it's just something that
I'm always going to do this.
I had a bunch of peanut butter and M&Ms today.
That one?
Creamy raspberry.
Okay, it doesn't seem like you'll have any questions yet, so I'm going to put these homeworks in gradebook real fast so I can pass them back to you.
I guess. Oh, not general. Or is that? Oh, that's the possible. And then you test it. Test it with
Now, to be fair, I did this in like at 7 p.m. after something happened. And then I got back from something. Yeah, I'm probably out of it.
Like that. Yeah, I know.
You test the points.
I think I put in
So I really do. I swear, that's what happened. I bet you that's what happened. I only do it.
Puerto Rico, that would be good.
this one was legit because I didn't think about it. Yeah.
That was like 2 days. That was the other day, I was for like 7 hours.
And then, yeah, now I'm only getting. Sector here, cavity yesterday. Oh wait, that's what I plugged in. I plugged in.
What happened with
What are you plugging in? Well, we have to plug in with stuff. At 0, that's a concavity. Then that's from a downward concavity to an upward one.
Oh.
The second derivative is 6x.
Wait,
This is first
Yes.
realized.
Yeah. Yeah, wait.
I got just.
Oh, no, no. He's got a little streak to it.
Oh, to find the point.
I bet you were putting in for.
Yeah, but
All time I bet it's a lot.
Okay, listen, I'm trying to check my answers, but people keep pulling me away from my phone. I'm trying to do it, okay?
I don't know how much I have on these
But yeah, I did this, but I didn't check my answers, so it's likely that they're wrong.
so it's gonna be really.
I even said this.
No, I'm just trying to, it's really strange when I'm really not. If I put that right in, that should be x, right?
Yeah.
Not, okay. I was like, that being considered a constant or not. I was, it was really trivial.
Okay.
And I was like, I should know that.
Second derivative. Second derivative. Oh,
Just found the other ones.
I feel like I need to write out.
That's part of the character.
Wait, no, how did you get 5 and 6? 0? No, give me your how would I know? Yeah, but that's
I and then at like
so that what? 32, right? I did take it.
okay.
No, wait, no. Everybody get 2. I don't know. It's like it's actually my bad.
I think you might be very.
If I pull up, well, now I got 5. Oh, wait, no, I can't do math. Hold on. Never mind. 8 plus 4 is roughly 9. When do you need something? That's easy. I literally get to use it. I was still, I did the math right until that part. So I got the wrong denominator. It's just a denominator. I just go too fast. That's my issue is like, wait. Okay, we got 6 on something.
Yeah.
That's the type of
One could say.
It's just the justification is because
Why did you
it just says because it's the relative jumps.
look at my
Stuff out.
I've never seen that in my life.
With God doing the AP test. With God, I went through the AP test. She was saying I'm like crossed out like half my page.
I still got that. I still got that.
2, maybe, 1, maybe.
I think
Straight with 3. I think I can scrape with 3.
Well, you need to split this up. You would need to say like,
What are you talking about?
add x equals whatever, spur to 5, 6, I think. What are you doing?
Jack, guaranteed 5 on those AP coverage.
Oh yeah. I was looking at AP code. I already have it.
Hey, me too. I bet you go check this.
Oh, so what
I
is
just hear so much stuff to go on. It's gonna be like somewhat hard.
I would say,
I just had
add
to
this
split.
time
The second
Also,
derivative
But I
goes from
I like fitters.
Well, yeah, we did everything right except.
Yeah, but this is last. So I've done that. This.
But she's teaching.
She
She
has
has
to
to
go.
Yeah, so changes. Nothing changes.
So like, yeah, it's all.
But we need to, because they're different reasons. This one's switching from negative to positive, and that one's switching from positive. So you need to do separate. What you're saying, like, is what you're broke down, you know, is what you need to correct. It's just not explaining how to do that. It's something that messes up my justification.
He said, no, you were, and I was kind of. See, I was spacing out. I knew like that's what I Yeah, she kept going in our class. Don't say anything about school.
The worst part was it was the open, it was the complete open response, like, it wasn't like doing something about it that we could base it off of.
Like, is that like a valid form of documentation? Yeah. I was like, sure.
Yeah, I mean, I don't see why not.
I mean, people have them or not.
What did she do?
I got through that problem there, so every question, and I just.
So I just randomly gave me looking at grass because the only part I'm getting 100% correct.
Wait, so
I
this
got thesis that,
Yeah, I got But then I did like, so on the whole, like a full practice. Oh, thank you.
Because it's a different problem.
wait.
That's yours?
Or wait, no. It's when directions change. Are you ready for the Oh, I just took the derivative.
Oh.
Yeah, but the difference.
Wait.
I haven't heard of
Did we do history of
so many questions.
Oh, because hey, I mean, can you ask, there's such a, there's the very real chance that I don't know. So, like,
I did it. Because I talked about how it's like, I forget exactly what I said. Yeah, no, it's a DVD. I don't know.
Every time you get
It's the one with the short, it's like the one with the short pass. But I talked about like whether, because like she doesn't do a lot of studies, so she might represent the one. It was that,
You'd be surprised, dude.
was
It's
that
like,
architecture?
the order like a $15 thing. But a lot of times, because you'd have to give them back. They would like let you keep
That's
like.
like,
Eminent domain.
They would just go, because when you go to the trouble, you know.
Oh, yeah.
Unless they
One just gave you
I don't know if you forgot those, or if they're wrong stuff, so I can find them.
I know you got other tasks.
I love people at church.
You take it out of cash.
I don't know, maybe ask me your advisory.
I'm looking like a lot of
I still imagine.
I mean, is that every?
Yeah, I definitely missed my life. I missed my life. Like, talk outside.
Is it?
It's not enough to just have an extra.
Yeah, no, you need a, just a smart little half. You need one of these.
Oh,
I don't know. No, that's not good.
And this one is when they.
that's all second. That's all second.
Yeah, I know.
Okay, your problem is when you set it equal to 0, you didn't solve the problem. And you subtracted 24.
I subtracted instead of.
Yeah.
Is this the one that
Mr. Townsend, I like this heater.
It's almost your
You
own
literally
personal
should put it on the screen now.
What's that only facing him?
I'm not, I don't think Why are you joking?
But the temperature stopped at 70, so I think too much heat is leaking out there. So now.
Wait, I heard that there's things
Oh, wait, no, I'm testing. I'm sorry. I was
Jack, we should have
It's cold
Yeah,
here.
sorry.
It is cold.
I'm switching
I
between.
wish you had done it.
Really?
Keeping it all myself.
It's
It's like right on me. I feel like I'm by a fire. I feel like I'm by like a fire. Hey, bro.
That's the easiest part.
Just say, we didn't track today, huh?
Luke, you can ball it out and make it lit. No?
We don't do the track today.
Yeah.
No, they're both.
It's just
We had our coffee this week yesterday.
I mean, if you're on like the other
You're better track. Shaq, you need it first, though?
All right, you guys are down to about 15 minutes of class time.
Oh, you're on 42.
800. I'm going to the 4x8.
You got it back yet?
It's a B.
Hey, but me and Trace and you got to lock in. Me and Trace and you are going to score 100 points.
Basically.
I'm going to win the 1 to 200.
Or maybe I'm wrong.
Me and Trace are going to win the 4x2. I haven't even gotten it correct.
I got it right. I remember I got it right. I mean, maybe if you have two, maybe if you have two.
Well, I texted Oliver and I
Let's
asked
say
him
relative minimums of the same value, are they both absolute
I don't
or
know.
neither
Neither
of
that
them?
we Snapchat. Well, I'll ask him next week in practice.
These have the same relative, but they're not absolute max.
What's that?
Or absolute max.
Okay, but then it goes, okay. They would be, because one of them, they would be absolute one. But then you add a floating, and then the second one has the same value. Would it be,
So who else
would
would
it be absolute minutes or would that?
Like in a sine function.
Nate is the closest
Yeah.
person.
Or
Anything
both
else?
of them or neither of them?
Okay, well, the absolute min
Yeah.
is still going to be the y value. So the absolute min is
No,
still.
no,
You were
the y
thinking
value.
about like
Yeah.
But like,
there's
absolute
nobody else.
min at-
Okay, and add, sure, then you would need to say add this x value and that x value.
Okay.
But that doesn't
you got 418.
I mean, I guess maybe I was thinking.
I might not. Nah, we need like, Loki put like,
Yeah, there's none.
maybe we find a football player that Nah, no football player can run it.
Oh. I gave up on it. I gave up it.
Football players can run it. 400. I definitely did not do that.
Can one of your
That's
projects
what
be
it
your
was.
No.
I would get absolutely the 200s. Like I give out before the 200.
I wanna go with my mom.
But yeah,
Not that I don't know.
mean, our supervisor's door is loaded.
Me and Riley go around the same time. I'm not taking it.
We're getting some football players.
Math related exercise.
Oh, we're getting, yeah, I got it.
I did it earlier, I decided not to wait.
Christian battles and stuff like that.
What the freak? I turned 42 in Mr. Townsend. Yes, I did. It's on Google Classroom.
Mr. Townsend.
That's why I'm giving you a hard time about your homework. I thought you didn't do it.
John, like, can you run me through like one of these when I'm
Oh my
sorry real fast what I'm
Lord!
I'm trying to watch the videos, but it's not, my computer's not loading right now.
Well,
I
I can't say
will
the
have to
whole thing
figure out where
quickly,
my
but
focus
the
is.
second derivative is positive.
Yeah.
The second derivative is negative is concave down. And where it's switching from concave up to concave down, that's very solid. This is like.
Okay, and then like some of these problems, like you're like walking through one of these, like this one right here. So like I'm taking the derivative twice. So why am I writing the second derivative?
Because you're trying to figure out concavity, you gotta know whether it's second derivative is positive or negative.
Oh, that's right.
So you find the second derivative.
Why?
On the
Find
second derivative.
where it's zero or undefined.
She gave me a 25 out of 30 on this unit discussion.
I got that.
Find where it's zero or undefined, because that's where it finds and changes the concavity. And then you plug in
Well,
numbers
it's for unit
into the
3.
second derivative around it.
Unit 2
Everywhere
is
it's
total.
positive, it's
I got
concave
a-
up, everywhere it's
I got
negative,
a
it's
25 out
concave
of
down.
25 in unit 2.
See where it's
I don't know.
positive.
Like, am I not talking enough? I think I'm
If
talking.
it's concavity,
I'm in period 2.
That would be a 20.
And which that has, which Palmer's in that room. It's so
Kind of like the second derivative.
This is the one that you
Over your hair looks really cute.
No.
Like, splitting my
There's
0
a
and
few
10
people
out
who
of
don't
10.
show up, and
Yeah,
she
she's
kept on
like-
getting on with it. And now everyone, the whole lot, everyone has a good
Oh, yeah.
I think she, I don't know. I think she just sort of takes 43. Takes like the highest she can, because it's like keeps being pretty consistent.
Oh,
Like,
no.
or 30 on the last one.
I just want to see if you trusted me enough. No, so this didn't record right for some people. You know, Gradebook does that sometimes. I did think you forgot your homework. That's why I was giving you a hard time.
No, I didn't. You
I need to go
messed up.
But yeah, Christian battles.
Okay, but to be fair, Google Classroom.
Yeah, I think AJC was down, so that might have been why.
No, like
He's our running back. He's manual running back.
there's two of you that turned it in this way. Almost nobody turns it in this way, so I don't think about it.
Well, I already took the pictures in my advisory.
That's fine. That's fine. That's my fault.
Top of my list.
That's what like Christian says. But yeah, he's out of backs. Like he'll be on our full So he's gonna be elite in the 60 class. Like he's not that.
Well, I was looking at two signs, because I think it says concave down, like negative.
Hopefully that brings my grade up back up to an A.
He's fast. Like he's.
They only have two orchids.
Jack, you say Christian?
This one doesn't.
That's son of
Him or Lamb, right?
Lamb?
I don't know if anyone's ever made an A that thought absolute max and mins were boring, so.
Well, they're boring, but I know how to do them, so. It's like, it's like, like sleeping. You need to do it, but it's boring.
Sleeping is boring?
He's fast.
Sleeping's my favorite part of the day.
Oh.
I'd go to sleep right now if I could.
Well, you need upper body strength to do that. Oh yeah.
What's your bedtime?
Jack, it's just as important. Jack,
Not
think
soon
about it.
enough.
Think about it. If you don't have any upper body strength,
I'll try to go to sleep by
your body doesn't
9.
sideways. You need upper
Asleep
body
at 9.
to like counteract your legs. You know what I'm saying?
I start my
So,
day
like,
and get home at 9. No, I can't.
Okay guys, we've got about 8 minutes. Make sure you know what your homework is. You need to check with me if you don't know.
they're like,
Are they like creamy? Or are they like, yeah, 'cause creamy is
Let me show you a creamy sandwich.
And the way I was like, I'm trying to think if creamy got like meat.
Creamy just downstairs. But it gets leaner.
Well, I was trying to say that creamy's like a body.
You done this?
You get like get more lean.
Bro, if you could like, so if you're like an athlete, bro, just you understand.
Did y'all do this last time?
Hey, Kendrick might be popping off.
Because if you wrote 1 for X on the bottom.
I have a logo quiz for you, and your task is to find the correct one. Let's start. Here's the first one.
So there's no point.
What's the correct Netflix logo? It's this one. I'm sure you got it right. We all like a good show. Let's go on with something a bit harder. Where is the real PayPal?
But yeah,
That's the one.
Bro, just think about it, bro. Like, every time
You probably stream music every day, but do you remember how many live Spotify has?
if you push on this leg, it's gonna push you this way. You don't use your arms, they track like this. Just like really like this. So like
It's this one, with 3 lines. Which logo is the correct one here?
but tracks all four. It's equal.
Yes, the one over there. Are you a coffee fan? This one's for you. Which logo is correct?
Like Quincy Wilson. But in sprinting, bro, you gotta get the perfect watch.
Yeah, because it's so quick. It's like everyone's like, every second.
This one, of course.
Please stop chocolate.
Now, how about Domino's Pizza? Which logo is correct?
Hey, Gibby's coming at distance. All you do is throw. Oh yeah,
That's the one. If you watch TV, you must know the correct NBC logo. It's your chance to shine.
Yeah, this is like this is the colors of the rainbow.
Here it is. I know it was hard. I didn't get it right myself. Ice cream people, this one's for you. What's the correct Baskin Robbins logo? It's this one. Blue, pink, blue. Do you have a MasterCard credit card? Then you should know this logo. But red and yellow, or yellow and red. Yeah, this is the one. Red and yellow. That's a fancy brand, but you've probably seen it around a lot. So what's your It's this one. Are you a Mac person or a Microsoft person? Which logo is the right one? Uh-oh, it's way harder than it seems, but the correct logo is this one. Coca-Cola is the most consumed drink in the US. The second place goes to Diet Coke. So, which logo is correct?
Some of these are way too easy.
It was easy, right? Of course. This one. The third most consumed soda drink? Pepsi. So find the right logo. This is the one. Take a closer look at these images and find the correct old school Disney castle. It's this one. If you got it right, I bet you've seen a lot of Disney movies. Subway is the 6th most profitable fast food chain. The first one is, of course, McDonald's. Can you guess the correct Subway logo?
Subway's the 6th most profitable.
Yeah, it's this one. LG with a dot or without. Yeah, of course the logo has a dog. Can you find the correct Sprite logo? Here it is. Great job. Are you a gamer? If so, you're bound to crack this one. If not, well, try your best. Yep, did you get it right? What's the correct Discord logo? Yeah, it's this one. No antenna. It's not red. What's the correct house arrangement on the Hogwarts coat of arms? Only true Potterheads will know. It's this one. Did you get it right? Another question for gamers. What's the correct PlayStation logo? It's this one. Great job. Especially if you have no clue about gaming. The most popular browser used by people worldwide is Google Chrome. As for Opera, it isn't even in the top 3. But I bet you know the correct That's the one. Another shout out to coffee and donuts fans. Can you recognize the correct logo? It's this one. Can you figure out the real Nutella logo? Right, here it is. Can you recognize the one and only Shell logo? Here's the first one. What's the correct Netflix logo?
There's no better. Well, I guess for throwing, it's not much for though.
Like before I put arms in
That is generally what things that shape. Have a nice weekend.
Thank you. You too.
Wait. Oh. Have a nice Berlin weekend.
Were you hoping it was Friday or something?
What?
I said, were you hoping it was a Friday?
Yeah, it went through.